Hi class, this is an example problem for unit 8.2, and for this unit I've prepared two separate example problems, so watch for the next video after. So I've just prepared a simple example where this is problem 822 in the book. We have a bunch of boards that are being held together by a clamp. The clamp is exerting a force of 200 newtons on both sides of the board, and we know that each board weighs 2 kilograms. And we are told that the coefficient of static friction between each board, so that each of these points is 0.3, and the coefficient of static friction between the clamp and the board, so here and here, is 0.45. So I've already basically drawn the free body diagram, but imagine there's a clamp that's pressing in on both sides of the boards. And what we're asked is to find the maximum number of boards the clamp can support. Now in this problem, the obvious question is, where will the boards slip? Will it slip between the clamps, or will it slip between the blocks? And if we're thinking about and kind of the way to think about it is that everything that's inside, within on the interior of the point we're looking at, we can basically treat as one lump with a combined mass. So thinking about it that way, it doesn't make any sense that like the interior is going to slip in the interior. It's going to slip on the outside, because if we were to think about this slipping surface, we have this larger mass. So I'm going to redraw this as a free body diagram, but we're going to have to check two things. We're going to need to check, will it slip at where the makes contact with the clamp, or where it makes contact with the board. So if I were to draw a free body diagram, I'm just going to imagine that all those boards together act as one big lump, and the weight of that lump is, so first I'm going to look at the case of slipping at the clamp. And the weight of that clump is going to be, so we know it weighs 2 kilograms, so 2 kilograms times gravity times n, where n is the number of boards. And we have these forces pressing in that are 200. And what's resisting that is the friction force. So let's call that, we can just 200 times 0.45, because this is between the clamp and the board. All right, so that's basically what the free body diagram looking like, right? We're looking at this collective clump of blocks that collectively weigh 2 times gravity times n. So all we have to do is just look at the sum of the forces in y equation. Sum of the forces in y equals 0, and based on this free body diagram, we know that that's going to be 2 times 200 times 0.45. So we're just combining these friction forces right at the get-go, minus 2gn, and we're solving for n. So let's see, when we do the math there, that gets us 2gn equals 180. And then that means n is going to equal 180 divided by 2 times 9.81, which gives us 9.174 blocks that could be supported, if we're assuming it slips between the clamp and the board. Now let's look at the other case where it slips not at the clamp, but at the contact between the first block and the next block. So what that free body diagram will look like is very, very similar. But instead of 2gn, now the mass of the outside blocks is no longer under consideration. So basically now it looks something like this, where you have these, just still the 200-pound force that's felt by all the books, or all the blocks. And at the surface, at these surfaces, we have friction forces of 200 times 0.3 now, because this is the contact here between blocks. And this collective weight is no longer 2gn, but it's 2gn minus 2, because we are not counting the mass of the outer blocks in the overall weight. So let's do sum of forces in y again. And it equals, again, 2 times 200 times 0.3 minus 2g n minus 2. And this value gets us 120 equals 2 n minus 2g n minus 2. And that means n minus 2 equals 120 divided by 2 times 9.81, which is equal to 6.1162. Then you'll move that 2 over, so then we get n equals 8.1162 blocks. So because that is less than here, it's definitely going to slip at this contact between the boards first. And you can't only have 0.1162 blocks. So the final answer is just n equals 8. N equals 8 blocks is the final answer for that. So hopefully that makes some sense in kind of thinking about evaluating what's going to slip first, where it's going to slip first when you're given multiple coefficients of friction. This problem can, I know there's one very similar to it in your assignments. It can look really tricky, but when you break it down, really draw down what is going on in the free body diagrams, you'll find it's actually rather simple to solve. So as always, if you ever have any questions, reach out to me. I'm happy to help or talk about these, and hopefully you find that helpful. Thank you.